This is the research project for ENPM 613, and our topic is design consideration for artificial intelligence software. My name is Hengcheng Shang, and my partner is Hang Yang. For the outline, firstly, I'm going to give an introduction of AI technology. Then we are going to talk about problems and solutions by the stakeholder of customers and developers. Then I'm going to give a conclusion and references. For the introduction of artificial intelligence, the basic of the artificial intelligence technology is neural networks, and the core of it is the machine learning. For machine learning, firstly we have deep learning, which the most famous application is AlphaGo, which use multiple layers of neural networks. And after that, we have reinforcement learning, which the most application is AlphaZero, who beat AlphaGo in the game. So for artificial intelligence, there are three fundamental software applications. The first one is NLP, natural language processing, and the most famous application is Siri and Cortana by Microsoft. And the second one is CVPR, the computer vision and pattern recognition, which can be used in autopilot car and auto photo tagging. And third one is algorithms for predictions and recommendations, which are also used by Amazon and Google for their website advertisement. But there are also many problems of the AI technology. Firstly, it requires large amount of data to train the model, and it also requires a lot of computational resources, such as hardware and time. And thirdly, it is unstable and unreliable compared to the traditional software. And last but not least, it has a phenomenon that we call it the artificial first and intelligence later. And for our analysis, we have two assumptions. First one is that the customer has limited resources, and the second one is the developer has to face very complex problems. And for the stakeholder of customers, the first point of view is about the cost. We have problems such as the AI project has more unpredictable develop period because we have to spend more time on training the model and editing the model. And then about the implementation and the test, it will also cost more time than expected. And also, if we have dirty data, we have to pay for more labor hours and hire more people to pre-process the dirty data. And also, it will cost more on the computer software. To solve these problems, firstly, we have to sort and grade our requirements according to their importance to guarantee the most important requirements will be realized. And secondly, we should use spiral models instead of waterfall models. And thirdly, we should manage to reuse those hardware and process the data to lower the cost. And for the point of view of security and reliability, we have problems such as the AI project has unpredictable outcome compared to the traditional ones, and it also has results that are not accurate enough for many applications. So for the solutions, firstly, we should lower our expectations because AI is not human brain, and also we should considering that combine human and artificial intelligence system for the best result. And thirdly, we should focus on narrow and vertical field instead of bandwidth application. And last but not least, we should build a high fault tolerance scenario while using the AI application, such as Google search engine instead of a dialogue system. Then I'm going to hand over to Hang Yang for the stakeholder of developers.
So from the developers' views, two major problems are noticed. First, developers need large amount of data to train their AI models. Second, unpredictable results by training models with different test cases. Let me further elaborate what I just said. The assumption I make is that developers have to face complex AI problems to be solved. As we all know, to teach an AI to understand or recognize something is not an easy task. It needs a huge amount of data to train the AI model, which serves the input to the model in order to let them produce the output feedback. So the question is, where to find this enormous amount of data? The solution for big companies like Google or Amazon is that they can collect and use their customer information through websites and applications that they use since these companies have large customer base. According to the article titled Customer Data Designing for Transparency and Trust in Harvard Business Review magazine, by tracking users' activity online, marketers could deliver targeted advertising and content. More recently, intelligent technology in physical products has allowed companies in many industries to collect new types of information, including users' locations and behavior. In this case, the cost will be sacrifice of user experience and possibility of leakage of customers' privacy, and benefits are customer data acquired. However, in order to let the small companies with less customer base to have the equal opportunity to showcase their AI products as well, the solution for them is BOTTOS, which is a decentralized data sharing network platform based on the blockchain technology. Quoting from BOTTOS white paper, by using the BOTTOS platform, AI product or services providers can attain specific training data in a more reliable and economic way, whereas the data contributors can declare ownership of the data as a personal asset and capitalize this asset via the token reward system. The token reward system works like this. BOTTOS will issue a token called BTO to reward the participants in the network. The AI product developers can purchase BTO and use it to reward the data contributors later if they have the need for data acquisition or other services such as data cleaning. In this case, the cost will be tokens to pay to the contributors and benefits are data acquired. Therefore, for both large and small companies developers, they will have the way to collect large amount of data to train and test their AI models. The second problem faced by developers is unpredictable results by different test cases, aka new training data that were used. One example would be the overfitting in machine learning. Overfitting means a model learns the training data too well to the extent that it negatively impacts the performance, since that it does not apply to new data and negatively impact the model's ability to generalize. To solve this problem, the solution is early stopping. Since we know overfitting is caused by using too many epochs to train the model over the dataset, so we should consider how many epochs, that is, how many full passes of the dataset should be used to train the model. And the early stopping can help developers to decide this value. The way to do early stopping is simply 3 steps. First, split data into training and test sets. Second, at the end of each epoch, evaluate the network performance on the test set if the network outputs the previous best model. Then save a copy of the network at the current epoch. Third, take the model that has the best test set performance as the final model. So this is the picture that shows how these 3 steps involve to produce the best performing model. The dashed line indicates where we should stop by early stopping epoch. So now I'm going to hand back to Hengcheng Shang to give us the conclusion.
So for the conclusion, artificial intelligence as a new area of computer science and a new form of software application. It can do a lot of amazing things, but it also have a lot of restrictions. So we should use our knowledge in software engineering to help to overcome these restrictions and also evolve our software design techniques at the same time for the future development. And here is some references. Thank you.